Okay, I was asked to help out with this problem, so let's take a look at it. The first thing I want you to realize is that when we have similar figures, their sides are in a constant proportion. So let's say that we have these two similar figures and their sides are in the proportion A to H. That's a single dimension. We know that in that case, any area dimension that is involved with those two figures, we saw that in the last unit, will have the relationship h squared over h squared, and any volume relationship, as we see in this chapter, will have the relationship a cubed over h cubed. What we are given is the area relationship. We are given 9 over 25 is the ratio between these similar figures as to one of their area dimensions. They gave us the area of the base. Knowing that, a single dimension, a side dimension, an edge dimension would be 3 to 5. Knowing that if h squared, small h squared is 9, then h must be 3. If large h squared is 25, then large h must be 5. We know that the volume dimension, therefore, is going to be 3 cubed, which is going to be 27, over 5 cubed, 125. So we know that is the ratio of the volumes for these similar figures. And we're told the volume of the small prism is 325. So we'll take this and we'll put 324 centimeters cubed over the volume of the large prism. So once we know our volume proportion, or the relationship between the volumes, which was based on the relationship between the edges, which was based on the relationship between the area of the bases, we can then solve, and if you work out 125 times 324 divided by 27, you'll find that x is equal to 1,500 centimeters cubed. A little tricky in that you're given information you have to get other information from, and then come to your ratio on your volumes, and then solve for the larger one. But it's actually a good review of the things we've been studying. If you have any further questions, email me.